in the pointers, we are the what is the difference between character pointer and integer pointers. So using character pointer, you can find your data is written in the format of little endianness or big endianness. So this is the most important question: how our data is stored. So it is in the little endianness format or big endianness. How we find out? If we don't know how we find out our data is stored in the little endianness or big endianness. So this is the program for that. Next is the difference between integer pointer and float pointer. So float f is equal to 3.5 and one float pointer integer pointer. An integer pointer and one float pointer I have taken. Then float pointer and integer pointer is equal to address of f. Int f. Star integer pointer is equal to percentage %d. And star float pointer is equal to percentage %f. Translation. And integer star integer pointer comma star float pointer. So what will be my output?
Address of F.
No, address of app, that means IP.
IP, yes, sorry, 3.5, yes. Pointer IP, then it is value, right? Okay.
And what is the star IP?
Same.
So I will first run this code. IP value is 108000333280. What IP value I got? 108000333280. And IP value is 3.5. What we are doing here? My float f is equal to 3.5. So this is my 1000 address of float f and the value is 3.5. Now I have taken two pointers. One is the float pointer, one is the integer pointer. Float pointer store the address of f, integer pointer store the address of f. Once I will access the data float pointer using float data, so I will get the data star fp is equal to 3.5. But once I will use the integer pointer and access the data of float, at that time it will give me 108000333280. Why? Because float data, so suppose I will do without pointer. So integer integer I and integer float f is equal to 3.5. Now I is equal to f. And what will be my I? I will be 3,
Yes.
right? So
Yeah.
this is
Integer.
normal values. We are
Hmm.
value storing the value. In the case of float, float data are stored in the IEEE 754 standard. In the memory, float data are stored in the binary format of the IEEE 754 standard. And once we are trying to use directly address and directly read data from that address, here this is the transfer float to integer. This is implicit typecasting. But here no any typecasting and we are directly accessing data, means indirectly accessing directly from the address. So at that time we are accessing the data of that binary format data in the format of integer. So it will give me the value whatever that available. So this is 10888800333280, this much bigger value because that last bit will be the signed bit. So you can see on Google also what is exactly the IEEE 754 standard. So I have opened the website Geeks for Geeks. So IEEE standard for floating point numbers. So here 32 bits are in the sign bit, exponent bit is 8 and Manitesa. These are the formats. And like this way our data is stored. 85 is different, 0.125 is different than 80.125 is different value. So like this way data you can see this. So in that format our data is stored. Because of that reason, if we directly use, so we will get that data. So write down in your book IEEE 754 standard for float and double. real number representation. So you should know how your data is stored in the memory. If you are using the float format, if you are using the integer format, if you are so integer and character. So in that case, we are using generally the signed and unsigned format. We have already seen that. If it is unsigned, then this is the positive number. It is signed, then it is the negative and positive both. Right? So in the case of real number, it is following IEEE 754 standard. Here IEEE 754 standard for float and double real number representation. So float is 4 bytes and double is size is 8 bytes. So here we have a 32 bits. Here we have a 64 bits. So signed or unsigned. So variable is signed or unsigned. That terms are not used in real number representation. Now I will divide my 32 bits. So float 32 bits, double 64 bits. So rightmost is the sign bit. Here it's a 1 or 0. Then is the exponent bit. So exponent is in the case of 32 bits, it's 8 bits, and in the case of 64 bits, it's 11 bits. And next portion is the significant, is 23, and here it's 52. And one more thing available, this is my 32 bits completed here, and this is my 64 bits completed. But one more terms available is bias. So bias is, we will see in the steps. So 7f value, that means is the in the decimal 127, and here is 3fff, 3ff. So it's in the decimal 1023. So first write down this table. Sign 0. Suppose my number is 3.5. F is equal to. So this is the positive number here, sign bit. Suppose sign bit is 1. That means my number is negative. First write down this table. Now we will see the steps. So I will draw the all the 32 bits. First one is the sign bit. Next 8 bit. Suppose I will do the 4 bytes like this. So this 8 bit are my exponent bit, and rest of the 23 bits are my significant bit. Okay. So first write down the steps, then we will see with one examples. So this is my sign, exponent and significant. So first step is convert the number into the binary format. So this is the first step. Convert number into binary format. So suppose my number is 3.5 or 3.7 or anything. So first you have to convert 3 and 0.5 both into the binary format. How to convert we will see in this example. Next step is convert the binary into standard binary exponent format. So convert the binary into standard binary exponent format. So standard binary exponent format is 1 dot x e raised to plus or minus y. This is the standard binary exponent format. So we are seeing real number in the case real life. We are seeing that 1.000 at e raised to plus or minus y. This is generally we are seeing standard exponent format. In the Excel, if you will write the bigger data, so it will convert into the exponent format. So similar way. So this is, for example, my binary is 1011.1010. So this is my binary format, suppose. So suppose any number is in the float or real number. So this is my binary 1011.1010. So I have to convert into the standard binary exponent format. That means 1 dot x e raised to plus or minus y. So that means I have to convert 1 point, and this 3 will be shifted to right. That means 0111010. So 3 times it shifted, then I will write e raised to plus 3. Suppose it's shifted left side, nothing value is here available here. So suppose my number is left side, then it's minus. It's right side, that means plus. So this is my standard binary, 1 point x e raised to plus or minus y. That means here 1 point, my x is 0 1 1 1 0 1 0. This is my x, and y is 3 plus 3. So this is my second step. Convert the binary into standard binary exponent format, 1 point x e raised to plus or minus y. Then third step, we have to add or subtract part with the standard bias number. We have to addition or subtraction, sub exponent part with. So here my plus 3. So e raised to plus, so that means addition. E raised to minus, that means I have to do subtraction. So e raised to plus 3, so I have to do 7f plus 3, because for float I have bias is my 7f, and for double bias is 3ff. So 127 with 3, what, so 7f plus 3, 7f is in the x, in the decimal it's 127. So 127 plus 3, whatever the value, this is the 130. So 130, whatever the binary of 130, I have to store into the exponent part. So 130's binary I have to store in the exponent part here. Sign bit is the positive number, that means 0, negative number, that means 1. Exponent part is coming from the step 3. So whatever the exponent, and then after significant, significant is my x value. So here x is significant. E raised to plus or minus y, we have to do addition and subtraction with the standard bias number. So x value, whatever the value, it's I have to put here, then rest of the 000. We will see with example. So this is my third step complete. Then fourth step, result of third step place in exponent portion, and result of second step place in significant portion. So like this way our binary of float number will convert, and it will store in the memory. So write down these four steps. So what is the binary of 3.5 and what is the binary of 3.7? So first, what is the binary of 3? 1 1, right?
1 1.
What is the binary of 0.5? So we have to find binary of the point number. So what we have to do? 0.5 multiplication with 2. That means what is my value? 1.0.
1. Yes.
So 0.5 binary is 1 0. Then suppose I will do 1.0 multiplication with 2. Then it's my 2.0, but my data will get in the 1.0. That means here I will get 1 value and here is 0. Then I have to not do anything. That means 1 I will get at the time, not go further. So my binary of 3.5 is 11.10. Directly 10 I have to write. Suppose in the case of 0.7. So 0.7 multiplication with 2 is 1.4. So here it's 1.4, not 1.0. So again we have to do 0.4. So here this is my 0.4. Multiplication with 2 is 0.8. 0.8 multiplication with 2 is 1.6. 1.6, sorry, 0.6 multiplication with 2 is 1.2. 1.2 multiplication with 2 is, here again I have done mistakes. 0.2 is multiplication with 2 is 0.4. Here 0.4 multiplication with 2 is 0.8. So see here 0.4 multiplication with 2 is 0.8. So this part is continuously repeating now. We will not get 1.0.
Yes.
Now 0.8 multiplication 2 is 1.6, like this way. So what is the binary of 3.7? 3.7 binary is 1.11 point. Here first 1, then 0, 1, 1, 0, 0, 1, 1, 0 raised to bar. So this part is continuously repeating. So I will put here bar. Okay, understood how to convert in the binary. So you have to do till 1.0. If you will find that is the similar parts is came now 0.4 multiplication 2 again and again repeating, then you have to put from there bar. So this is the binary of 3.7 and this is the binary of 3.5. So what is our first step? First step is convert the number into the binary format. So we have convert this number into the binary format. So write down, we will take example of 3.7 because it is little bit complex one. And step 1 is the convert number into the binary format. Here bar is not in the upper side of 1. It is upper side of 0, 1, 1, 0. Okay, next step is convert the binary into the standard binary exponent format. So step 2. So standard binary exponent. So what is our binary? First I will write down the binary 10.1010110 bar. Right? We have to convert into the standard binary exponent format. Standard binary exponent format is 1.x is raised to plus or minus y. So here 11.1010 bar. So how I will do 1.110110 bar e raised to plus 1. So this is my standard exponent portion. Here this one right shifted by one time. So my dot will come here. So this is the one number only. So plus 1. So this is my step 2. Then step 3. So what is my here? 1.x e raised to plus or minus y here. My x is this part. X, this means significant. So I got my significant 110110 bar. Now I want to find my exponent portion. So exponent portion, I have to go into the step 3. Step 3 is add exponent with add or subtract here. Here my plus 1, that means add. Add exponent with standard bias number. So for float, standard bias number is 7f, that means 127 plus 1. So my number is 128 and 128 binary is 10000000. So this 8 bit will put in the exponent format, exponent portion of my 32 bits. This is the significant bit and we know this is my number is positive, that means sign bit is 0. So now you have to tell me. So I will write down step 4 also. The result of third step, place in exponent portion. Okay, this is my 4. Now you have to tell me the what will be my binary. So I will write down here. So now I will write here my 4 bytes. So this is my sign and these 8 bits are my exponent and rest of the 23 bits are my significant. So what will be in sign bit? This is the positive
1.
number. Positive number, that means my sign bit is 0.
Yes, yes.
Then exponent, third step.
1.
Okay. And significant, second step, this one. 1.110110 and 0110 raised to bar. So this part will be my significant. X. X is my significant. So this binary is like this way. I will write 1 1 0 1 1 0. This bar, that means this is continuously repeating. So I have to write down like this way: 0 1 1 0 0 1 1 0 0 1 1 0 0 1 1 0 0. till the end. I have to continuously write. So this is my binary of 3.7. In homework, you have to do 23.5, 3.5, these two numbers. So what is the first step is the convert the number into the binary format. Second step is the convert into the standard exponent portion. And third step you have to do addition or subtraction with the standard bias number. And fourth step, result of third step put in the exponent portion, and result of second step, whatever the significant part, put in the significant portion. Positive number, that means 0, negative the number, that means 1. So I will quickly do one more, p48.c. So binary format of float. So how to print binary format of float? So I'll write down the code. Float f is equal to 3.7. Then I will take one integer pointer and one I variable. Integer pointer is equal to address of f. So I have the address of f. For I is equal to 31, I greater than or equal to 0, I minus minus. So in the printf, I will print percentage d, comma, star ip, that means I have a number. That number I will do right shifted by position, ending with 1. It will print the binary. Then after printf slash n. So this is the same program like we have did in the normal variable case, but here we are doing using the pointer. So star ip, that is my number. I am doing the number right shifted by position ending with 1. So I will get my number is on that particular bit is set or clear, right? This program you already know we are doing using the pointer. So now I will run this code. So my output is C here 0, then 1, 0, 0, 0, 0, 0. This is my exponent portion. Then 1, 1, 0, 1, 1, 0. Then 0, 1, 1, 0 continuously repeating. 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1. So here I have did one mistake at the it is completely repeating. Then last bit will be instead of 0, 1, 1, 0, 0, 1, 1, 0. Here 1 we have to put last bit.